Um,
Okay.
oh, yeah. Oh,
Okay.
so your intro didn't get recorded.
Ah.
That's unfortunate. Okay.
Could you please come
Yeah.
out?
Okay, thank you, Makoto, and thanks for all of you to give me this opportunity, for giving me this opportunity to speak. So as you see here, there's a lot of material that's available out there that will relate to some of the things that I'll talk about now. So this is the one that is this spreadsheet, which has tons of links and everything. The other one is the QR code for my homepage. And I've also put the slides already on the web. So that's the URL. It's basically capital C, capital M, KJ 22. So bit.ly, the capitalization matters. So this is my life story, basically. I've given it in a number of places, different countries, even in places like Google and Microsoft, India, Microsoft US, IBM. I gave this presentation almost as it is on the last day of my IBM job, which was June 30th, 2020. So this shows you a bunch of people with whom I've either actually done technical work together, written papers together, or they are people who have been well-wishers of mine. So in that category, you see Theo Harder, who was the editor who dealt with my AV's paper for the SCM transactions on database systems. It's 60 something pages paper, probably the longest paper ever published in TORS. You also see Phil Bernstein, Patrick Valdurias. He invited me on a sabbatical to India, for instance. And then there are lots of other people, both product people and IBM research people who worked with me. Andreas Reuter was one of the referees of that TORS paper. Later on, he told me that he was a referee. This guy was the one who hired me. He's a Microsoft fellow, hired me as a consultant. That was my first consulting job after I retired from IBM. And this man was a computer science professor in IIT Madras, who encouraged my crazy behavior of being a chemical engineering guy who got terribly interested in computer science. And he was my bachelor's degree project guide. They allowed me to do a project in computer science, even though I was a chemical engineering guy. On and on. So you'll see Mike Carey and Dave Dewitt and various people like that. I don't have the time to in detail talk about people. This lady, she is the mother of cost-based query optimization. Some of you who were in my talk, was it day before yesterday or day before yesterday? In Osaka, you saw my picture with her. She hired me into the R-Star project, perhaps selling. She's considered the mother of cost-based query optimization. She's Stonebreaker also here and so on. You saw this picture actually that day in the other set of slides. So, as you probably know by now, those of you who have heard me speak before, I tend to say what comes to my mind. I don't try to be politically correct and things like that. So, of course, when I grew up, the environment was very different across the globe. There was no internet, nothing. When I started my bachelor's degree back in 1972, when most of you were not even alive, I guess. And also, you know, the research environment in India and all that was very backwards, hardly anything being done in terms of computer science research, especially. And even as a company, IBM has gone through huge transformations during that time. I've been there from December 81 to June 2020. And in terms of, we were just while walking around here talking about first class travel, economy travel, business class travel and all that. I can handle anything. I don't need to have the fanciest of things. If they are available, I will of course benefit from them. So I've lived in Silicon Valley now for almost 41 years, and I still didn't get tempted to become an entrepreneur and get into startups and try to make overnight millions and things like that, right? So I was happy doing what I was doing at IBM and having impact on the rest of the world as well as the IBM products and so on. So I did spend a few years in India after I joined IBM, because I was the IBM India chief scientist during that almost 3-year period. based in Bangalore. Because of the crazy things I do, just like this week, for instance, or uh, in about 10 days, I'll be in Hong Kong doing like 6 talks in 6 working days, stuff like that. Same day I give 2 talks and things like that. Um, so this meant that, of course, my wife and kids didn't have me around at home all the time. Because I did travel, as you'll see later, in terms of technology transfer. Even within IBM, I did a lot of travel, and then of course to research conferences and so on, outside too. And my wife herself was for a while in IBM, so for 11 years, and then she quit her programming job and became a writer and things like that. And kids, they're now 32 and 28. So happens that my daughter was born about, I think, a year and 3 months after I named my algorithm Aries. She was born with the zodiac sign of Aries. It wasn't planned that way. It was kind of funny. Of course, I spent my entire full-time career at IBM. The whole time I was never a manager. Okay, so I intentionally stayed out of management. So I was what they call an individual contributor the whole life. But I became a fellow after about 15 years at IBM. So for 23 years, I was a fellow before I retired. That itself is an executive position. So I might have been a non-manager, but that doesn't mean I'm a nobody in terms of the ranks. So even though I was not formally a manager, I still did that to think about the sorts of things that managers think about. Because even as a non-manager, I was asked to sometimes get involved in ranking people or get involved in making decisions about whether or not somebody should be named a distinguished engineer or a fellow and things like that. So in that sense, I had to think about their career goals and what they have accomplished and so on. Just like when you interview people, you have to evaluate them, or when you referee papers, you have to evaluate them. I cared a lot, not just about making money or just writing papers or just having product impact, but I wanted a combination of all of that, right? A certain amount of money is important, but beyond that, having more money doesn't necessarily mean you have more job satisfaction or personal satisfaction or happiness level goes up or any of that. So I don't say money is not at all important. It is important to have a decent lifestyle, and especially in Silicon Valley, it costs a lot of money to buy a house and all that. So I cared about what other people think of me in terms of my knowledge or technical contributions, how they are valued and such. So to that extent, I urge you all to market your work. Just doing good work is not enough. You have to make sure that if you really solidly believe that what you have done is a great piece of work, you better be able to communicate that to other people, communicate the passion and all that, and why you think yours is a big deal contribution. Of course, whether you follow my advice or this or that, or look at my life history, and if you religiously do the same things, you might or might not get the same results, just like they say about car performance numbers and so on. So you already heard, some of it, so I won't dwell too much on it. Once I got excited about computer science as an undergrad, I started doing lots of things on my own. And, of course, in those days, it's not as simple as sending a request via email to somebody to send a paper that you notice this person has published and so on. Everything required doing things the physical way, writing a letter by hand, putting it in an envelope, paying the postage, international postage to send it to Ted Card sitting in IBM Research or Mike Stonebreaker sitting in Berkeley. And I was on the mailing list of a lot of these people, and they had to then send the damn papers by mail also. No PDF, nothing, right? So if you think life is hard now, you have no clue how hard life was. With this punch card way of interacting with the computer system, 256K of memory and 6 hours, 7 hour turnaround time for a compilations result to come back, and then you have a syntactic error and you have to go through the same damn thing afterwards. So lots of things here that you can go read offline. I did write a couple of survey papers even as an undergrad. And then when I came to US for my PhD, they said, hey, you should get this published somewhere here so that more people will have access to that stuff. So in that sense, I was fairly well informed about what was happening in various parts of the world, in particular in the Western world, whether it's AI or databases or programming languages, operating systems, and so on. So I landed up in August 77 in UT Austin without any assistantship, because on paper I didn't have anything to show other than long, paragraphs where I described I have read about this system, that system, I played with the system, and so on. On paper, in terms of credits and so on, I couldn't take any computer science course for credit. The only course I could have done was a Fortran programming course in my third or fourth year. That's it. And I had started programming in my second year of the 5-year bachelor's program. So luckily for me, once they saw me in person, within 10 days after arriving there, I got a research assistantship. So all the money worries disappeared. My parents were a bit happier that after a year of hanging around in Austin, if I still didn't have assistantship, they would have to take more loans and all this kind of stuff. So I wound up finishing my qualifiers fast, but then it was a pain in the butt to find a thesis topic. So I was changing advisors, this, that. Ultimately, when Silverschatz and his ex-student, who had become a faculty member, showed up, Don Fussell, that's when the previous set of advisors said, hey, maybe you should, with all your interest in databases, go work for these guys. So that's how I wound up doing it. But then, in a year's time, I finished my thesis work. And as Makoto was saying, it's all theoretical stuff and not even fancy theory. It's neither fancy theory nor real systems work, somewhere in between. So I'm not particularly excited about what I did, though I got a lot of papers and people thought I was some expert in locking and this and that, but it was all, in my opinion, impractical stuff. So, but still, while I was doing these things, I thought by going and working in some place as an intern, maybe I'll get thesis topic ideas. So I actually wound up working 2 summers in Europe. And later on, this INRIA, the French Computer Science Research Institute, is where I wound up doing a sabbatical. It was in 98, 99. Patrick Cordurius, who I referred to, was the guy who invited me to work in his project as a visiting research home. But those things still didn't give me thesis topics, But I wrote this paper, which was highly critical of a system that was being developed in Computer Corporation of America, where even Phil Bernstein and Papadimitriou were advisors. They were faculty members at Harvard. And so even as a student, I ripped apart the design, which had been highly touted as the greatest thing since sliced bread. They published a lot of papers, not just in conferences, journals, and all that. And so that was a bit of a shock for some other people, especially the people who were working on the system, for them to find a PhD student and nobody criticizing their thing and so on. So I felt that it was very impractical in various ways. So this actually wound up giving me a lot of visibility in the minds of people who were systems-oriented people, like Jim Gray, Bruce Lindsay, Pat Selinger, and so on. So that later on helped me get a job. Even if they were not happy with my thesis topic, I had shown that I can think in a more practical way through this review that I had done. Because the CCA guys made sure I didn't get to publish it in any important place because they were not happy that I was so critical about that system, which made tall claims about why it's the greatest since man invented whatever. So thanks to all that, even though I applied to a few places, only industrial research or semi-industrial or semi-commercial, like Lawrence Berkeley Lab, for instance, I didn't even, as a fallback option, apply to universities because I was so keen on getting to know about real systems and dirtying my hands and so on. So I didn't want to continue to do very academic oriented work even after graduation. So luckily for me, I managed to get a job at the birthplace of relational databases, SQL and so on, which is what then used to be called the IBM San Jose Research Lab. A few years later, we moved to a different location in San Jose, and the name got changed to IBM Alameda Research Center, where Ukshin has done a postdoc also. So essentially, I joined the follow-on to the original System R project, which was the context in which SQL got developed. And that was the project called R Star, which was the distributed database version of System R. And Pat Selinger, who I referred to before, she was the founding manager of that project. So she wound up hiring me in December 81. And if you go back to this photo, so this guy, Guy Lohman, arrived in the same project 4 months after me. He took over the query optimization area from Pat Selinger. Laura Haas, who was my contemporary at UT Austin, she arrived 4 months before me into the same project. So the three of us joined 4 months apart. And Laura became a big deal person. She later became an IBM fellow and so on. And Pat also, some years after me, after I arrived, like 94, I think she was named a fellow. I became a fellow in 97, Laura sometime in 2000 something, and so on. So that project actually became a source of lots of IBM fellows, and I've listed Hamid Pirahesh also, who joined that project at the tail end and so on. But the first piece of work I did long before Aries was this variation on two-phase commit called Presume Abort, which subsequently became very popular. And in fact, outsiders implemented it commercially while before IBM did it. I prototyped it in RStar, and it became an international standard and so on. So if you look at a lot of distributed systems books, you'll see this being talked about. In terms of what happened at the end of the RStar project was the starting of a project called Starburst, whose goal was to, from scratch, build a new system based on the experiences gained by not only IBM people, but also others who had built earlier systems in the relational context, as well as even not pre-relational systems. Even though the original goal of the Starburst project was to look into the extensibility aspects of database systems in the client-server environment, I, the transaction kind of guy, said, okay, I'm going to go back and see what System R guys concluded at the end of the project and revisit, certain things that happened since then, and address concurrency and recovery also as an important aspect of the Starburst project. Although some people in the project said, why are you wasting your time? We tried to solve this problem of write-ahead logging with fine granularity locking at the end of System R, and we didn't succeed. Why do you think you are going to be successful here? Because Jim Gray and Bruce Lindsay and so on had concluded the way recovery was done in System R was not good, the shadow page recovery method, and that write-ahead logging is the right approach. But they tried to come up with something better than page locking, and they couldn't. And so they convinced, as a result, the relational database product people, in particular the DB2 product on the mainframe, to go with only page locking. So, but then the field experience with that was that it wasn't good enough, that they needed something better than page locking, a record locking kind of scheme. So the product guys were interested in my exploring that topic, hoping that maybe I'll come up with something that will solve their problems. But some of the research people who had been part of the original System R said, hey, we tried it, Jim Gray, Bruce Lindsay, blah, blah, blah. Why do you think you will be able to hack it? And so they said, in any case, the Starburst project goal is not to address this kind of topic. It's only extensibility and client server. So I had to have enough mental strength, that to say, okay, just because you're a senior person, I'm not going to listen to you unless you give me more justification. So I'm going to further explore this. This is a golden opportunity that doesn't come up too often, where you get to design something from scratch. And after all, we are in the research division, so we are not under, the product kind of constraints in terms of having to deliver something quickly and so on. So the rest, as we say, is history, in the sense that I got lucky or whatever, that I came up with something that was a much simpler variation on what VB2 had implemented, which was right-hand logging, but with page locking, thanks to the advice of these other people. And with some minor variation, I was able to then make that same kind of approach, where they did redo first and then undo, which was the opposite of what System R did, and so on. These are more details about areas that I don't want to get into now. I was able to solve this problem in a fairly simplistic way, and it also dealt with recovery being handleable more efficiently because of various reasons that I won't get into now, which had some problems that even tandem kind of database systems were suffering from, where if during recovery of the system you have another crash, then the recovery time, the second time around, was going to take even more. What was already undone had to be undone and things like that. So there was lots of interesting problems. But the thing was, in terms of getting the damn thing published and so on, or even to figure out what was done in the past, to see what worked, what didn't work, how they did certain things, and what kind of thinking they had might be the stumbling block to coming out with a better algorithm. I had to do a lot of my own work, because they didn't document a lot of the things that were done in System R, including how partial rollback happened or how index locking and recovery happened. And so I had to actually go through some age-old code, research prototype code, as well as even product code, to understand things that had not been even internally documented, let alone documented in terms of external papers and so on. So it's that kind of hard work which goes beyond the typical, I imagine some algorithm, do some performance evaluation, compare it with some obvious alternatives, and produce graphs and make it look very scientific and all that. And this is what I call the Wisconsin model of paper writing. You do some very high level design, not detailed enough for anybody to implement any of that stuff in a practical way. But it looks very scientific because you're comparing A, B, and C under this condition, that condition, and so on. Not all of those conditions may be very realistic in a practical sense. So I stayed away from that kind of work. So you'll find hardly any graphs in any of my papers, because even getting one algorithm that handled all the situations was hard enough that anything is better than something half-assed was the kind of thing that I had to deal with. But interacting with the product guys and getting to know what the real world problems were and what customer problems were there, and why certain things that the research guys thought might be cool ideas didn't work in a practical sense, why upward compatibility or evolution in a gradual way rather than revolution sorts of things are important. Even things like what Microsoft SQL Server guys did later, we couldn't afford to do, which is, we are going to change completely the page formats, going from page locking to record locking. So in order for the customer to take advantage of this fancy new record locking, you have to unload all your data, install the new version of the product, and then reload all the data, because it's changing the page formats, right? Whereas our marching orders where customers won't put up with it. So we have to do in-place changes in a way where you just have to reinstall the new version of the software, but the data has to be left in place as is. That meant that I had very little room for doing some innovative stuff. There were 2 bits in every page that were unused, believe it or not, in a 4K page. That's all I could use to do some magic with respect to space management in the context of record locking. So it's stuff like this where it's sometimes very painful stuff that you have to figure out. And you have to also say, here are the different things that need to be changed to make DB2 go from page locking to record locking. So it's this kind of follow through, which goes far beyond just coming up with the algorithm and doing the, in some ways easier thing, but following through that actually made the product guys take my recommendations and sincerity and all that seriously. And they felt good that I was actually thinking like them and working with them. And so this enables your ideas to get incorporated in a more welcoming way by the product people than if you had to do something, throw the result across the wall and tell the product guys, hey, you guys go figure out the rest of the story, because then they feel they don't have a skin in the game, that you are not giving them, the joint ownership of the idea, or make them co-authors on your paper and so on. So they would say they might have this not invented here syndrome. They would rather figure out something that might not be as good, but they feel they gave birth to that idea that allowed them to feel good and so on. So I don't know if it makes sense to a lot of you, but once you get out of the university and go to the real world, you will see some of this, or even during internships, you might come across these sorts of things. So this idea of my working with the guy who's the second author on the paper, Aries paper, Don Hadderley, who was the chief architect of the mainframe version of DB2, who later on became the CTO for all of information management IBM. He and I, working together in a very collaborative way, we said it's a good thing. Can we formalize that so that more of these sorts of collaborative things will be done by product and research people? That's what caused this DBTI to be established. So anyway, the result of all this was that a family of algorithms, Aries, XYZ, I started putting out papers on. Aries IM for index management. I did something else for linear hashing and so on. Not all of it got implemented and got commercialized, but bulk of it actually did. And so over the period of time, the technology not only got into database systems, but also into any system that was doing transactional way of maintaining persistent data. So that means that even messaging and queuing systems and document management systems and so on incorporated the Aries family of algorithms, even transaction monitor like Encina, which was developed by a company that came out of Carnegie Mellon, Alfred Spector and Rick Rashid and people like that. Even a distributed operating system like Quicksilver that was developed now and then. And then there are other companies whose products, as well as research prototypes and so on, that incorporated it. So here, Wuxin, you see, the other day, Q Young Wang sent me a message saying, you have used the word Cosmos, and that's only a data manager used this long-winding name because he made a lot of progress in taking the research ideas developed at KAIST and turning it into a big deal thing. So it sort of got into many textbooks and so on, right? So it's taught in many universities and things like that. So the difficulty I had in going from the initial set of ideas and hope that I could come up with something to actually making it have impact was non-trivial. Because first of all, the whole topic itself, people said, what the heck, who cares about concurrency in recovery? It's a solved problem. Phil Bernstein and a couple of other people have written a book on recovery in database systems. So what is there to do anymore? People take too many things at face value. They don't do enough homework to realize a lot of these things are very fluffy stuff and it doesn't actually solve the problem. So I was grilling some people 2 days ago. Did you deal with, in your work on concurrency control for B trees and so on, single action transactions or multi-action transactions? There were a gazillion papers written, but they didn't actually address the real world problem of a single transaction that does multiple actions against a B plus tree, for instance. And on, things like that, right? So I had to first convince people that there is a problem to be solved, that what was thought to be a solved problem or solved domain, or nothing more is there to be done kind of domain, is actually full of open problems. And then I had to also make sure that I beat up on people who just simply reject my papers and so on. So once some people tried to solve the same problem, like the Exodus project at Wisconsin and such, Mike Carey, they do it, they realized, oh, I can't find enough stuff out there. They didn't want to invent stuff. They just wanted to implement it, but they couldn't find enough stuff that worked. So that's when once they came to know about the Aries paper, they became my evangelists. They started telling other people, hey, go read this paper. But I also had to, shove papers under the nose of various people that I thought should know about the work. I didn't wait for them to discover that I've written a paper. I actually, myself distributed the paper, which in those days meant even putting it in envelopes and putting it in the mailbox and so on, not PDF. So it's that kind of way of socializing the results and telling about it and going and giving talks at the universities. I volunteered to give talks, just like I volunteered to Makoto about coming here while I was being invited by Wuxin to come to South Korea, is what made you guys invite me here, right? So I have no shame in telling people, I'm going to be in your town. Would you like me to come and give a talk, which I've been doing now for the Hong Kong trip, right? So from one talk, it's gone to now 6 talks. But it's that way of, not just telling other people about your work, but also finding out about what they are working on and, learning about areas that might not be your mainline area of work, but even related areas and such. I won't consider myself an expert in query optimization, but I, track what's going on. And so I volunteer to give talks sometimes and thereby force myself to learn more about a certain topic. So it's stuff like that that allowed me to then go do technology transfer. And it happened all across the IBM product organizations in various places. Even when we moved from bipolar chips to CMOS chips, because they are cheaper and other various things that are favorable to CMOS. Initially, the CMOS CPUs were less powerful than the bipolar CPUs. So workload that ran on a single IBM mainframe, if you want to now move that machine from being bipolar to CMOS, you needed to collect a bunch of these machines and make them work together to get the equivalent amount of horsepower, the MIPS. Which meant that if you don't want to force the customers to partition their database and so on, which relates to that earlier point, you want to simply roll in these machines, leave the data as is. What that means is that you need to support the shared disks architecture, where the database system will run on these multiple machines, which are acting like a cluster, and they are all able to have access to the same set of disks. And the application can run on any one of these machines, and it has equal access for read as well as write to all the data in all the disks that are attached in a common way to this cluster of machines. This is different from the shared nothing architecture, which is what Tandem, Teradata, and later on a lot of the university projects were claiming is the right way of managing large volumes of data and get parallelism and so on. So Dave Dewitt and Jim Gray, all these guys were proponents of that approach, whereas in the IBM mainframe, we went for shared disks, which had been tried before by a bunch of other companies and so on, including Digital Equipment, which did it for RDB. Later, Oracle developed their technology based on the model of what Digital did, which was originally called Oracle Parallel Server, and later on it came to be called as RAC, the Reliable Availability Clusters or something, which is the name today for Oracle's way of doing things. So things like that allowed me to influence even messaging and query systems where we needed better concurrency than even record locking, because the message queue head and the tail are hotspots. We can't transactionally make changes to them, where if one guy adds a new message, we can't wait till that guy commits before you let somebody else be able to handle. And by the same token, if somebody removes a message from a queue, you can't wait till that guy commits before you let somebody else be able to remove a message from that queue. So we needed to treat some of these things in a more semantic way in terms of increment, decrement style locking rather than exclusive locks and so on. So I gradually also started moving into other areas like workflow management and things like that, and document management. There were other projects where I didn't have as much success in terms of whatever I and my collaborators invented necessarily getting picked up for commercialization. But some of the things here, in other talks, I go into details about hybrid transactional and analytic processing, which is currently very popular. I'll be discussing this in my presentation on trends in database systems and so on. Some of it I also discuss in the cloud database systems talk, which I'm going to give in Mohan in a few days. And if you go look at that spreadsheet, you will see lots of other talks that have been announced for Hong Kong, starting in about 10 days. And some of those talks are ones that you can actually remotely attend. So I strongly encourage you to do that if you're interested. I also started getting into blockchain, and then I wanted to do a better job in the blockchain space than what had been done before, where they were using NoSQL systems. I wanted them to be able to use SQL. So anyway, because of all this kind of work and the perseverance I showed, and question some senior people's just blanket statements about why you shouldn't bother with this, you should just do this kind of advice, resulted in coming out with something that was counterintuitive to the senior guys' original statements. So because of those the well-wishers that I mentioned before, I happened to be the first non-American guy to get the Sigmod Innovation Award, and that was way back in 1996. Next year, I was named an IBM Fellow, which is the highest technical position you can get in IBM, right? Which is similar to, later Microsoft introduced the same sort of concept and so on. And things like this started happening, okay? This important point, a lot of people think that unless you become a manager, you won't be visible in your organization. Guess what? Towards the end of my India assignment as the IBM India chief scientist, for about 6 months, my manager, who was at the time the head of the research division, started reporting to the CEO of IBM. So my second line manager was the CEO of IBM. So depending on your organization and how much it values technologists, if they do have a technical ladder separate from the management ladder, and there are some people who play both roles, people like Laura Haas, Amit Prayesh, and so on, they did take up management, unlike me. Pat Salinger also obviously was a manager since she hired me, and later on she became a fellow. But I chose to stay technical because I was having enough fun and I didn't feel that I needed to become a manager. And so in a company like IBM, which values technologists, this kind of thing is possible. In a company that at that time probably had 350,000 employees or so, right? So even later on, the CEO knew who I was, and even the current CEO knows me, Arvind Krishna, for instance, right? So in summary, it's easy to go with the flow. Whatever is currently fashionable, you just join the fray and do some delta work. Whether or not that delta work is of any value, you feel good that it's a better algorithm than the other guy's algorithm, which is the best until then. The definition of best is also questionable. Is it best in a more theoretical sense or in a practical sense? How do you characterize what is success? Is making a lot of money successful, or having gazillion papers a sign of success, or getting a certain award a sign of success? With a lot of these things, you as an individual have to decide what is it that you consider to be important. So I tell people upfront, you have to decide, is owning a sailboat a sign of success? Is climbing Mount Everest a sign of success, and so on, right? Depending on your area of work and such. The environment in which you get to work is also important, right? In my case, I didn't need to be taught about what it is to have a long-term technical career, because there were enough people like Ron Fagan and Pat Salinger and Nick Peppinger, theoreticians as well as practical people that were around me. Even Ted Cott was there for 2 years after I joined, and then he retired, right? The father, Don Chamberlain, uh, unlike the other guy who died soon after he did the original sequel work, Ray Boyce, Don Chamberlain was there till 2005 when he retired. Pat also retired around that same time. So the atmosphere was such that during lunchtime, that informally, I learned a lot. Whereas there are environments where in India and China and so on, even in IBM, there weren't enough senior technical people in that geography for people who might want to get inspired to, on a regular basis, get to meet and informally get inspired. So we had to give talks to them about technical ladder and things like that. They couldn't, in a very casual way, learn about all this and get inspired. And I also tell people, even if you are in the product world, you should still care about your visibility. And even in an organization like Google or whatever, Facebook, where a lot of the database systems developed might have been for internal use, the minute they start offering them on the cloud, they better now start worrying about how much they publish and how much their system is compatible with other systems, whether standards are being followed, there are enough tools and so on. So suddenly these guys who might have said, I don't care about what the rest of the world does, do have to begin to worry about it for their cloud products to be successful and things like that. It's also good if you're more collaborative than if you think I should, hide all the new things I've done and write a paper and then only expose it so that I don't have to give credit to somebody else in my group who may have some way of improving it and so on. So this keeping things close to heart. In some cases, some people do that because at the end of the year, the evaluation criterion says, what did you do as opposed to what you group of people did? So for individual promotions and all that, they want to attribute credit very carefully, especially in India, especially in the US. So for that reason, it becomes a dicey proposition. Doing group work might be good overall for the organization, but when the time comes for promotions and all that, they want to, on a per person basis, clearly identify what this person did versus that person did. So that's one reason why sometimes people get a little too carried away, and also, who's the first author on a paper and multiple authors and all that begins to matter. So in any case, you can see what all I've said. It's also easy to stay in one area forever and keep on doing something, but it takes a certain amount of courage as well as investment where you don't have something to show because you are learning this new area and what has gone on and so on. But you could bring a different perspective from the previous area in which you worked, that the people that have been working forever in that area. Even in my case, the Aries stuff, I didn't have the baggage of a certain way of thinking that the system guys had. So that helped. And I was willing to look at other things that had been done, which these system people were not, looking at closely enough to see why, IMS did right-head logging and the way they did record locking and all that was superior to the page locking stuff that they later on recommended to do in the relational context. So stuff like that requires that you do fair amount of investigative work, where while you are doing that, you might not have enough things to show that are publishable and such. But sometimes people get too carried away with wanting to have a quick return on investment, and that's the problem. They want to quickly do something, publish a paper or claim credit for having done something. They are not having the patience to, over a period of time, breathe and live and think about something, not just at work, but even while you are showering or lying on bed and so on. So anyway, this is the slide I showed on the last day when I was leaving IBM. Is the joke obvious? Have you seen this logo? But what used to be here? No, it used to be just the letter M. Okay, they use the I for the letter I, they use the B for the letter B, and this used to be just an M with that hash, right? The IBM logo stripe, where there will be horizontal stripe. So I said, I had been in IBM for 1/3 of its lifetime. IBM is about 100+ year old company, right? So I said, I deserve at least one letter. And especially when M is Mohan. So I hooked up this. Okay. So I post my retirement, that Microsoft fellow that I mentioned briefly, he asked me to consider consulting for them. So I'll let you read these things in your leisure time. On the first day of my consulting, I posted this joke about consultants and how they work and all that. And then at the end of the day, I got all excited and posted this long thing on Facebook saying, it's so nice to see people still, spending so much effort in working on hardcore databases, when in fact IBM and some other companies maybe are getting too carried away, going with the flow and, talking about quantum compute, working on or talking about and investing in quantum computing and AI and cloud, but they've sort of forgotten, continuing to invest a lot in the hardcore database area. So I got very happy, and now I'm discovering, Google is also investing a ton of money and so on. And as I showed the other day, Google's gone past IBM in terms of the top 5 vendors out there as of 2021. And I've also been doing other things like being an advisor and being on a university's board of governors, and continuing to do the professional stuff like being the industrial program chair for this year's VLDB and things like that. So unlike the Microsoft one, which was a short duration one, because then I moved to Singapore for being the visiting professor at National University of Singapore, where I taught a seminar course. The Google one that started in March is still going on. Okay. That's about it. Any questions, comments? See, today I finished on time.
We welcome any questions.
Of course, you can also ask me outside of the session, since I'm going to be. Yeah.
You told us to remind you of something about
About?
Heidelberg.
Oh, Heidelberg Law. Thank you. That was a good one. So I was over dinner last night in the table that I was in, referring to the Heidelberg Laureate Forum. So go look for it. Heidelberg being the city in Germany. They once a year have this gathering of winners of 5 prizes: the Turing Award, the ACM Prize in Computing, and then there are 3 math prizes, including the Fields Medal, the Abel Prize, and the Nevelina or something. This Abel and Nevelina's existence, I didn't even know until I got to know about this HLF and who gets invited. Fields Medal, you have to be less than 40 or 45 years old to get that math prize. So they bring them together. Of course, not all of them attend, typically about 30 of them attend. And then 200 young researchers are the people who are the target of that event in terms of them getting to interact with these laureates, as they are called. This is modeled after a similar thing that goes on in Germany that has been going on forever, which allows Nobel laureates to interact with younger researchers in the various domains in which Nobel Prizes are given. So Andreas Reuter, that I mentioned before, he cooked up this idea of doing it for computer science, and then went to one of the founders of SAP to see whether he would fund this activity. And that guy, Klaus Schira, he said, how about adding the mathematics prize winners also? And so it's gone on now for 8 or 9 years, I think. So they try to pick people from across the globe, but you have to apply first of all. So the people who can apply are undergraduates who are studying, graduate students, and people who got their PhDs within the last 5 years, obviously in mathematics or computer science. And so a single person could actually attend it 3 times, because you could start with undergrad, you get selected as a grad, and then as a postdoc, whatever. Industry people are also allowed to go, as long as that within 5 years after your PhD condition is satisfied. And 100 of the 200 people will be mathematicians and the others will be computer scientists, and about exactly 100 men and 100 women. So they try to be equally, cognizant of making sure that it's not a men-dominated thing, right? So go look it up. So there'll be a call for papers every year, and the event is in September, second week, I think, the second full week of September or third full week of September. And generally, they expect you to pay your own way to get there. And then once you are there, everything is taken care of. But if you have a financial need, then they do have some scholarships for paying for the travel also. Okay. Thank you. And I was told that not too many people from Japan and Korea show up there. So I've been there twice as a special invitee. I'm neither a young researcher nor a laureate. So my work on blockchain allowed me to get invited over there twice. So every year they have a notion of a hot topic. And one in 2018, the hot topic was blockchain. So I got invited as an expert to take part in it.
Any
Yeah.
others? Yeah.
Did you ever, any differences in your major, like, here?
Yeah, like I said, once that computer came, any regrets? Well, no, I mean, I was so excited. See, the thing was, in the 5-year bachelor's degree program that it used to be at the time, the first 2 years were common across all disciplines of engineering. Only from the third year on, we'll do discipline-specific stuff like chemical, mechanical, electrical. So I got hooked to computers starting from the second year, beginning of the second year, which is when that mainframe, which was a gift from West Germany, arrived in the institute. So not having the ability to do a bachelor's degree in computer science, not just in IIT Madras, even outside of IITs, there was no place in India where at that point undergraduate program existed in computer science. So in a sense, I was whiling away my time just getting some bachelor's degree in an engineering discipline. And the IIT branding also was a good thing to have. So no, but it so happens that when I was in UT Austin, there is this guy, Alex Bookman. He was technically a PhD candidate in chemical engineering over there. But guess what? He actually worked in the database area. So basically, he was working on how to model chemical plants in a database context. So he nominally has his PhD in chemical engineering, but his work was actually a database. And probably many of you know who Alex Bookman is. He used to be in Darmstadt. He's now retired, but he has done a lot of good work, even in the CCA organization that I mentioned at one point. Any other questions, comments? Yeah, go ahead.
So nowadays, with AI or blockchain or quantum, so many, new timings
Right.
happens. So what is our, the role of the database?
Oh, wow.
In 10 years?
Actually, so if you had come to my talk on or listen to, of course, you were busy in the US, day before yesterday's talk, I did talk about the application of AI in the databases and also how database ideas could be used in, making more efficient the pipeline that ultimately leads to the building of a model and benefiting from AI models. So there are a number of things that are going on. I talked about incorporating AI kind of techniques into the database system, both for the benefit of the internals of the database system itself, self-organizing data, this, that, right? Query optimizer benefiting from it, as well as to improve the performance for the AI algorithms that you can have instead of extracting the data out and running the AI logic outside of the DBMS, just like you do stored procedures and UDFs and all that get invoked from within the bowels of the database system. Can the AI stuff also be invoked from within it? So there's lots of stuff that is in progress and being worked on in various places. And even the management of the AI models, if you want to have good governance around it, I had mentioned that some people have written papers on what better thing to do than to treat even the models as like data and storing them within the database system and applying the usual rules about authorizing usage and tracking provenance and all this kind of stuff. So there's ample stuff to do. And by the way, I do have a presentation on AI past, present, and future. Like I said, I tracked even stuff that went on in the US while I was an undergrad in India, including speech understanding by Carnegie Mellon people and so on. So based on some of that and what I learned also in IBM about how enterprise AI is different from AI in social media kind of companies or e-commerce companies, that presentation you'll find in the spreadsheet again, the links to not just the slides, but even videos of that presentation I've given in a number of places. In fact, my first time talk on blockchain happened in Hong Kong, but the original reason for that trip in April 2017 was to give a talk for the first time in my life on AI and enterprises at the invitation of some software technology park in Hong Kong. So since then, I've enhanced that talk to include a lot more material. So I cover stuff from the Stanford data center, I forget what it's called, data science center or some such thing, where they provide actually lots of interesting statistics every year on what are the hot topics within AI and what are the different universities and research centers which are producing work. Any other comments? Yeah.
I think as you said, after graduating your PhD, you wanted to authorize more practical things.
Right.
So
Especially because for my own thesis work, I didn't do anything, no implementation whatsoever.
all the theory.
Yeah, that was one of the problems. Even though Silberschatz was a systems guy, he wrote textbook on operating systems and database systems.
Mhm.
As a way of doing research, he didn't have the idea of implementing systems and such like they did in Wisconsin and MIT, Stanford and Berkeley and so on. So in that sense also, I felt not just my thesis work, but even the environment in which I grew up in Austin, there wasn't that much of system building kind of way of doing research work.
The apply that was the real work.
I mean, even these prototypes are not necessarily very practical things, right? But if you don't do even that kind of academic prototyping and academic way of looking at applications, you are that much far away from really practical industrial strength and so on. Right? So I, at least for the initial stage, wanted to go into industry, but industrial research, not just products. Because I cared a lot about this publishing and all this kind of stuff and getting pats on the back from various people and such, right?
Mhm.
So I wanted to have the cake and eat it too. And I then realized, oh, this IBM lab is a fantastic place that enables me.
Yeah.
So I didn't feel anymore after that, oh, I've had enough of my real world stuff. Let me now go to academia, kind of change of heart. So, and by the same token, taking up management, I didn't feel was a necessary thing to have success and things like that. So, however, I chose to define my notion of success. So that's one thing you all have to think about. What turns you on might not be the same thing that turns on somebody else.
Yeah.
But at the end of the day, you should still have some criterion to decide what defines success. And so for some people, they say after a while, enough of doing all this. I want to leave this big company, go start a company and feel good that I can build something from scratch. I can be the janitor in that startup as well as the CEO and do everything in between and give other people jobs, this, that. So there are various ways in which people justify going away from doing certain things to doing some other things. And then you have the stonebreaker kind of people who still have their feet in the academic camp and turn every one of their projects into startups, and then they make money by selling them to other companies and such.
Excellent.
Yeah, sure.
Just to have me.
Have I already blown my time?
No, you still have 2 minutes.
Okay. Yeah.
So I'd like to hear your opinion about research in academia and in company. So which is better?
Wait, I didn't catch all that. So you want to hear about research in?
Company, industry, and
Uh,
in academia.
oh.
And for example, some people like Onizuka Sensei, he previously worked in a company, but then he moved to
Academia?
university.
Mm.
And
Yeah, so I mean, it depends, right? So in my other talk, I briefly talk about all this, which is the systems, database systems and so on. I talk about the fact that even my own original place of work, with all the de-emphasizing of the work on the database topic, it's sad, right? Because now, in terms of really high-class work being done, it's Google research, non-academic institution. And sorry, not Google research, Microsoft research. It's QCRI, and pretty much that's it. Because Oracle doesn't have a real serious research lab. They might have 2 or 3 people, they're calling themselves research, but Google research is not focused on database topic. They're all spending a lot of effort in all sorts of other things, AI in particular, and research on ads and various things, right? Search and so on. So naturally, as a result, some people might say, forget it, I want to continue to do research. I don't want to necessarily move to Seattle, whatever the reason is that they don't join Microsoft research, right? And so such people might choose to go to academia, or sometimes people say, and we discussed this actually last night, I think, you might be forced to work on one topic in the traditional industrial research context. You're attached to a project, whereas when you are in academia, you might be able to simultaneously have your fingers in multiple projects, depending on where you get your funding and so on. So there's lots of pros and cons about this. In fact, 2 nights ago, dinner is when this discussion took place in Osaka on industry versus academia. And there are any number of panels that are held in the PhD symposiums attached to Sigma and BLDB and so on, where this kind of thing is discussed. So I can spend quite a bit of time discussing the pros and cons in terms of having to fend for money in the academic environment. You have to apply for grants, and you might not have as much freedom as you think you have there, because the funding agencies get to decide what are the topics you get to work on. Unless you have your own money and you don't care for getting funding from somebody else, you don't care about getting promotion. I've had these arguments with some academics also who claim, I can do whatever I want. I'm like, that's just BS, because if you want to get promoted and all that, you are an academic dean and so on, also has an influence on how they look at what impact you are having and so on. Are you able to attract enough good students? It's not just you as this professor individually doing stuff, very rarely, unless you are a theoretician, right? In systems area, you still need a group of people, and how do you convince a group of people to work with you rather than the other professor? And how do you get industrial sponsorship? So I actually tell people, even if you know for sure you're going to get an academic job, don't think in a silly way like some people recommend them. Some advisors tell them, who cares about industry internships? If you're going to be a professor and that's your lifetime goal, don't bother with internships. I'm like, that's so stupid, because if you go have the industrial internship, first of all, you'll get exposed to a lot of interesting problems. Your subsequent academic work as a faculty member will be that much more practical and so on. And by the way, it can also help you with the networking that you have done for these industry people to give you, IBM academic grant, this, that, and so on, right? Microsoft does these things. So in so many ways, it's important for you to get exposed to stuff that you might not get to do as a regular thing because you were chosen to go into academia. So
Okay,
Thank you so much.
Sure, thank you.
Thank you, see Mohan. Yeah, great.
By the way, later on for that record.